Okay, welcome to today's short focus lesson on the basal ganglia. One of my favorite topics in neuroscience is the basal ganglia. So what do? Select, energize, integrate, and drive our motor strategies. And it all seems so automatic. And you'll understand more about what I'm talking about as we go through here. Application. So how are we going to use today's information? So this isn't just about learning all the components, all the pathways of the basal ganglia. Really, once you understand the structure and function, that hopefully is going to help you able to design and deliver movement interventions to improve movement in persons that have basal ganglia dysfunction. For example, people that have had a stroke within the basal ganglia, persons with Parkinson's and Huntington's disease. Again, it's not neuroscience information just for the sake of learning it. It's to understand that once you understand the anatomy and the structure and function, you can appreciate the signs and symptoms that the person is going to display, and you can design interventions that will take advantage of, exploit the intact areas of the cortex to improve movement. Okay, so essential questions. So at the end of this session, you should be able to answer these questions. What is the unique role of the basal ganglia in motor control? What is the structure that underlies this role? So how is the basal ganglia set up to allow this role? What is the result of basal ganglia dysfunction? What do you see in a person with a movement disorder? And how can movement be impacted or improved in persons with basal ganglia dysfunction? Okay, in order to answer those questions, this is what you need to know, and hopefully what we're going to get through here. We're going to describe the basic anatomy of the basal ganglia, describe the major basal ganglia cortical loops, and we're really going to talk about one today, which is the skeletal motor loop. And then we're going to describe the direct and indirect pathways in the basal ganglia. Fairly complicated. We're going to take a fairly good overview of the direct and indirect pathways. And hopefully at the end, you'll see how when the structures aren't working properly, the movement disorders that occur as a result of basal ganglia dysfunction. Oops, and I meant to take that slide out. So we're going to go right here to the main components of the basal ganglia. I know you've heard this before when you had neuroanatomy back in term 2. So we're going to go over these quickly. But the basal ganglia encompass 5 nuclei. Remember that ganglia is just a group of neurons. Okay, so here's 5 big groups of nuclei. And remember, these are subcortical structures, so they're deep to the cortex. So we have the caudate, which is right here, the putamen. Those are both the input structures of the basal ganglia. One has more cognitive role. The putamen is the one we are most concerned about. That's the input structure, part of the basal ganglia that's concerned with this motor control loop. The globus pallidus, which has 2 parts, the GPI internus, GPE externus. This is the output structure of the basal ganglia. Those are right here. So you have putamen, caudate input, globus pallidus output. The other 2 parts of the basal ganglia are the subthalamic nucleus, which we're really not going to talk about today, and this is substantia nigra, which is located in the midbrain, and you all know that because that's where dopamine is produced. So essentially, why this is important is because the basal ganglia require dopamine to function properly. Okay. So another way to look at it, if we look at functional roles, the input into the basal ganglia is through either the caudate or the putamen, and for our purposes for motor control, it's mostly the putamen, okay? And it gets input from a lot of different cortical areas that we're going to see in just a second. The substantia nigra acts as a modulator. It produces the dopamine that allows the basal ganglia to function properly. And the output is primarily through the globus pallidus internus. Okay, and then let's put it into the larger context of the whole brain. So this is a busy slide. These are all the loops through the basal ganglia, but I want you just to focus here on the the left-hand side of the screen. Okay? So this loop starts off in the primary motor, premotor, but particularly the supplementary motor cortex. Oops. Sorry, guys. So information, cortical information from primary motor, supplementary motor, and premotor is coming down, and it reaches the putamen, the input structure of the basal ganglia. From there, information is transferred to the globus pallidus. That's the output segment of the basal ganglia. From there, information goes to the ventral lateral and ventral anterior nuclei of the thalamus, so thalamus, and then look where it goes. It goes back up to the same place it came from. It goes back up to the primary motor, supplementary motor cortex areas. So this is essentially a huge feedback loop. Okay? Get information from the cortex, goes to the putamen, globus pallidus. Globus pallidus sends the information back up to the thalamus and then back up to the motor cortex where it came from. So something is happening. What is happening? Why is the motor cortex doing that? Why is it sending this information to the basal ganglia? Well, let's try to go a layer deeper and figure it out. So there are two pathways, what we call pathways through the basal ganglia. A direct pathway, which is a shorter, faster pathway, and an indirect pathway, which is a little bit longer. Couple things you need to know. The primary output of the globus pallidus, the output section of the basal ganglia, is inhibitory. Okay, and all these components in the basal ganglia use GABA. Okay, so let's work our way through it. Let's talk about this direct pathway. So don't panic when you see this slide. So I want to first focus your attention, this is cortex, on this pathway right here. Pink, right, sorry guys, pink, right here where it says direct, GPI, thalamus, and back up. So we're just looking at this short loop right here. You can disregard this for now, disregard this. We're looking at this more internal loop. Okay, so it's just what we just talked about. This information is coming from the cortex. It goes to the putamen. The putamen sends it directly to the globus pallidus internus. Globus pallidus internus goes back to the thalamus. Thalamus goes back up to the cortex. Okay, that's the path. But let's look at what's happening inside the path. Pink means excitatory pathways, and gray mean inhibitory pathways. So what's happening here is, yes, the cortex is turning on neurons in the putamen, but the output from the putamen is inhibitory. And the output from the globus pallidus is inhibitory to the thalamus. Output from the thalamus is excitatory to the cortex. So if you follow this through, basically what's happening is you're inhibiting the inhibitor. Okay, if left all on its own, the globus pallidus would inhibit the thalamus, reduce the amount of excitation back up to the cortex. But we're inhibiting that. A minus and a minus. A minus and a minus makes a plus. So the net result of this direct pathway is you reduce the level of inhibition coming out of the GPI, and that increases the excitation to the cortex. The net effect is excitatory. Okay? So you have to think of the direct pathway as putting on the gas. It puts on the gas pedal. It energizes movement. It helps select movement. Okay? Say we were planning a hand movement or a finger sequence movement. Say this is like the fingers corresponds to somatotopically the index finger and the primary motor cortex. This comes down. Remember that all these components are somatotopically organized. It excites areas of the finger neurons in the putamen. That goes through the direct pathway. You inhibit the inhibitor, so you're creating net excitation back up to that same finger area of the cortex. Okay, so it's energizing it. Yes, we want this movement. It's facilitating it, allowing it to happen. That's the direct pathway. The indirect